Hello and welcome. In this lecture, we will create a new feature branch named JPA, set up the Spring properties required by Spring Data JPA in memory database, add the Spring Data JPA Maven dependencies, create the JPA entities required to implement authentication and authorization, and finally, close the Git flow workflow by merging the JPA branch to develop. In the previous lecture, we have gone through the physical database model to implement Spring Security for our website using relational database persistence. In this lecture, we want to lay the foundations for a database-based security model. To do this, we will use Spring Data JPA. For those of you who aren't aware, JPA stands for Java Persistence API. JPA provides a way to deal with persistence from an object-oriented point of view, rather than a physical one. Indeed, by the time we complete this course, the same JPA model will be used to store data to an in-memory database for development purposes and to a physical MySQL database when we will be deploying to Amazon Web Services. The beauty of Spring Data JPA is that we won't have to change our code to persist to different data stores. Building on what we have learned in previous lectures around profiles and external properties, we will persist to an in-memory database when running with a dev profile, and to MySQL when running with the prod profile. The first thing we need to do is to create a new feature branch where to write our JPA implementation. We will start by making sure we are pointing at the develop branch with the git command git checkout develop. Please note that sometimes I don't run this command in the video, as I'm already on the develop branch. However, even if you are already on the develop branch, running this command won't have any side effects other than Git telling you that you are already pointing at the develop branch, so you can run it safely. Then we will create a new JPA feature branch with the git commands git checkout -b JPA, git push -u origin JPA. Spring Boot offers great support for JPA to the point that it has a module dedicated to it called Spring Boot Data JPA. The first thing we'll need to do is to set up some properties in the application dev properties file. As discussed earlier while developing, we will be using the H2 in-memory database. Therefore, since we are running with the dev profile, we know that the development config class will load the application dev properties file. We need to add some Spring Data JPA properties to this file. From previous lectures, this file should be located in your user home /.devops buddy folder. I've already added these properties to the file, so please pause the video and take your time to ensure that you add the same ones to your configuration. The Spring Data Source URL property defines the JDBC URL for connecting to the H2 database. Here, we are defining a database named testDB. Because we are using Spring Boot Data JPA, we need to disable the automatic database shutdown when the JVM stops. We do this by setting the DB close on exit option to false. We have also indicated that we want the DB to run in MySQL mode, as our production database will be MySQL, and we want to make sure that our code will work with MySQL too. Then we have the default username SA with a blank password. We then have a couple of JPA properties to make our life easier when debugging the application. Spring JPA shows SQL tells Spring to show the SQLs that the framework will automatically generate when running our code. The Spring JPA properties hibernate format _SQL tells Spring to format the SQL nicely so that it's easy to read. Finally, the Hibernate dialect property instructs Hibernate to use the H2 dialect when running. Now, we will need to add a few dependencies to the POM XML file. First, we will add the Spring Boot Starter Data JPA dependency under the Spring Boot section. Then, we will need to add the H2 database dependency. We can create a new section in our POM called Spring Data and simply add the H2 artifact with the com.h2 database group. We don't need to specify a version, as by importing a Spring Boot Starter Data JPA, the right version is already managed for us by Spring Boot. That's all that's required to set up Spring Data JPA. By simply adding the Spring Boot Data JPA dependency, Spring configures for us a data source, transaction management support, a JDBC template, JPA repositories support, which we will be looking at in one of the next lectures, Hibernate libraries in case we want to use them, Tomcat JDBC pool, and much more. Because Spring Boot implements configuration by convention, when it finds the H2 dependency in the class path, it automatically sets a connection to the H2 database. To test this out, we can start by creating the simplest table possible from our architecture diagram, which is the plan table. Under the backend persistent domain backend package, let's create a plan class. We will have it implement the serializable interface and declare the constant serial version UID with value 1L. I've created an IntelliJ Live template to create this constant, and I suggest you do the same, as it will save you some time. If you don't remember how to do this, please look back at the lecture on logging and SLF4J. I'll show you the one I've created so that you can pause the video and follow the example. We will annotate this class with the @entity annotation. Spring JPA will take the class name as table name. If you want to customize the table name, we can use the @table annotation, although it's not required in this case. First, we will create an empty constructor. This is important with entities. Although we know Java provides one by default, to avoid disappointment, make sure to always declare one explicitly for entities. This is because later on in the course, we will create more than one constructor to build our entities. You know that if you have a non-default constructor, the default constructor is not available to the JVM. For entities, this causes an error. Therefore, make sure to always have one. We will then create an int variable called ID and a string variable called name, for which we will also create getters and setters. We use int as type, as we will have a tiny number of plants, in our case just 2. We will also create hash and equals method based solely on the ID attribute, as this is the primary key. To indicate to the JPA entity manager that ID is the primary key, we need to annotate it with the @ID annotation. The @ID annotation is required for entities and is required to be placed on the primary key. That's it. If we restart our application now and look at the console messages, we will see a nice and formatted SQL which shows that Hibernate is creating this table for us. Now we can create the other tables required to implement persistent security. Let's start with the user table. We can create the user class under the same package that we've used for the plan class and have it implement the serializable interface as well as declaring the UID constant. We will annotate this class with the @entity annotation. I'm now going to copy some code I've prepared for this lecture to save you some time, and then I'll talk you through it. We have declared the ID as primary key with the @ID annotation. This time, we have added the @generated_value annotation with the strategy attribute set to generation type auto, as we want the database to automatically assign user IDs when we create them. Then we have added the properties as per our architecture diagram. Please notice the @column annotation. When we want to override the default values, which are set to the attribute name, we can use this annotation to define the physical column name in the database. Finally, notice how we have declared the foreign key to the plan table. We haven't declared a plan ID attribute. Instead, we have defined a plan property and have added a couple of annotations to it. @many_to_one informs the entity manager that there will be many users with the same plan. When looking at a relationship annotation, like many_to_one, you need to always look at it from the perspective of the entity where this annotation is being defined. The @join_column annotation defines the column name on the user table that will be used as a foreign key. If we restart our application now, we will see the sequence that Hibernate generates to create these two tables. Notice the final alter table user statement, where Hibernate adds a foreign key to the user table. Great work! Now we need to create the missing two tables. Let's start with the role table. Again, we will have it implement the serializable interface and declare the UID constant. We will annotate it with the @entity annotation and then define the ID and name attributes with the respective getters and setters, as well as the hashcode and equal methods based on the ID property. We will then use the @ID annotation for the ID attribute to indicate that this is the primary key. This time we want to specify the ID value ourselves, therefore we won't be using the @generated_value annotation. We will come back to this table later to complete the many-to-many relationship. First, we need to create the user role table. I'm now going to copy the code for this class from some code I've prepared for this lecture. Please feel free to pause the video and copy exactly what you see on the screen. This table is pretty simple. Similarly to what we have done with the user table, we have declared 2 foreign keys to the user and role tables, one of type user and the other of type role. As usual, we have implemented the serializable interface and defined the UID constant, as well as declared a public default constructor. We have also declared the equals and hashcode methods based on both user and role properties, as this is a combined primary key. We have annotated this class with the @entity annotation. Only this time we have also set the @table annotation to the value user_role, as we are not happy with the default name. For the user and role attributes, we have defined a many-to-one annotation. Remember that this is from the point of view of the user role table. There will be many user IDs linked to a single ID in the user table, as well as many role IDs linked to a single ID in the role table. We have also defined the fetch attribute to be eager. This means that if, for example, we scan this table with a select operation, it will eagerly fetch user and role data. This might or might not be what you need. For now, we leave it there. We can always change it later. The last thing we need to do is to revisit the role and user tables and set a @one-to-many relationship to this table. Let's start with the user table. The process will be similar for the role entity. Now, please pause a second and think from the point of view of the user table. For each user ID in this table, there is the potential of many roles in the user role table. What's the best Java type we can use to indicate many occurrences of the same object? Exactly, a collection. In particular, we will use a set to avoid the duplicates. So, let's go ahead and declare a set attribute of type user role in the user class. This time, we will annotate it with the @one-to-many annotation. Since if we update a user, say we delete a record, we want all records in the user table for the user to be deleted as well, we will set the cascade attribute to all. Notice also that we have declared the map_by attribute with value user. This value identifies the attribute name that we have used in the user role entity for the user relationship. Finally, we have set the fetch attribute to eager, as, when we read a user, we want to get all their roles straight away. Make sure that you also declare getters and setters for this newly added property. We will need to do the same for the role table. We will declare a user role set, only this time the map_by attribute that we use in the annotation will be set to role. Again, we will declare getters and setters for this property. If we restart our application now, we should see all the sequels that Hibernate generates to create the tables, and there should be no errors. If you are experiencing an error or problems with your code, as a reminder, you can always refer to my GitHub repository and take the code from there. You can also send an email to elearning@devopsfolks.com and subscribe to our Google group. Finally, we need to close the Git flow workflow. First, we will push the current code remotely with the git commands git add *, git commit -m created the JPA entity model for Spring Security, and git push. Then, we will merge the code to develop with the git commands git checkout develop, git merge JPA, and finally git push. That was great, guys. We have now laid the foundations for persistent security. We have learned what Spring Data JPA is, how to set it up, and how it works. We have learned some of the JPA most useful annotations, how to declare entities, tables, and column names. Very importantly, we have learned how to declare relationships between entities, and I have to tell you that as part of this exercise, we have implemented the most difficult relationship, which is the many-to-many. As part of this exercise, we have also implemented @many-to-one and @one-to-many relationships. We are not done yet. First, as much as our application starts without any errors, we don't have any ways to test that everything works correctly yet. Additionally, we will want to access some sort of H2 client where we can see our database structure. We will go through these topics in the next lecture, where we will be learning Spring Data JPA repositories, we will create various services to manage CRUD operations on entities, and we will be writing some automated tests to prove that CRUD operations work on our security model, as well as setting up the H2 console. Thank you for your time, and I see you in the next lecture.